Hello and welcome to your lesson on negative exponents. I want to first start building on what we learned with exponents the other day, and we did an example similar to this where we had some number raised to a power. Let's just say it's 5 to the 6th power, and we're going to divide that by 5 to the 4th. Well, we realize that 5 to the 6th just is exactly the same as 5 times itself 6 times. And 5 to the 4th is 5 times itself 4 times. And when we go to simplify, since we are working with multiplication and division, and those are inverses of one another, we can go ahead and cancel out any operation where multiplication and division are happening as long as it's the same value. So each of these sets of 5s can then be reduced out. So we're left with 5 to the 2nd power, which equals 25. Okay? Let's take that same fraction and let's apply our rules of exponents. So according to our rules of exponents, since we have the same base, our base is 5, and they're being divided, the rules of our exponents, if you kind of think about your MDAS chart, says we can take the same base and rewrite it, but I can take the exponents and subtract them, which gives me 5 to the 2nd, exactly the same as we came up with earlier. So let's consider what happens if you take the original problem of 5 to the 6th over 5 to the 4th, and we take that fraction and use its reciprocal. So compare that to 5 to the 4th over 5 to the 6th. Well, 5 to the 4th, we've already done this, but we'll do it again, is 5 times itself 4 times. 5 to the 6th is 5 times itself 6 times, and we can notice things start to cancel out. All right, now, this is what I see a lot of. A lot of people say, well, there's 2 5s left, so 5 squared is 25. But that doesn't make sense because we're taking a small number on top and dividing it by, a number on top and dividing it by something larger than that number, and you're telling me I get an answer greater than 1. That's impossible. If I take a number and divide it by something bigger, like 4 divided by 5 is definitely not bigger than 1. 5 to the 4th divided by 5 to the 6th, there's no way that could equal 25. So let's think about what may have gone wrong. Well, I agree that everything dropped out except 2 of the 5s, but what I want you to recognize is that these values, anything divided by itself, is really just equal to 1. So you have a bunch of 1s that are being multiplied in the numerator. Well, 1 times 1 times 1 times 1 is just 1. So instead of being 25, we're going to end up with 1 over 25. Okay? So, leading us into negative exponents, let's use our rule from up above. Our rule up above, we had the top number minus the bottom number and gave us 2. Well, if we do that same logic here, the top number minus the bottom number would be 4 minus 6, which gives me negative 2. So 5 to the negative 2 has to be exactly the same as this number over here, because we just showed we're working with the same problem. So how does that relate? Well, let's see what that actually means. Trying to find the new page on here. Bear with me. Okay, there we go. So we said 5 to the negative 2 was exactly the same as 1 over 25. In other words, 5 to the negative 2 was exactly the same as 1 over 5 squared. Okay? So at this point, I want you to grab your notebooks and pause the video. In your notebooks, I'd like you to write this rule down. Negative exponents simply mean that the base and its exponent need to move to the opposite location. In other words, if it's in the numerator, you have to move it to the denominator. And if it's in the denominator, you have to move it to the numerator. So we'll try a few more of these just so you can kind of see what this is going to look like. Okay? If I take x to the negative 5, well, that just means that's supposed to be x to the 5th. But right now, technically, x to the negative 5 is in the numerator. So how do we get rid of the negative exponent? Well, we bring it to the denominator, but the rules state you have to have something on the top of your fraction. The only thing I can put in the top of a fraction that doesn't change its value is a 1. And that's because multiplying and dividing by 1 don't change the value. All right. I'm going to write one up on the board. I want you to pause it, and I want you to try this one on your own. 3 to the negative 7th. Pause the video now and try this one. Okay, hopefully you got 1 over 3 to the 7th. Again, the negative 7 just means instead of being in the top of the fraction, we had to move it to the bottom of the fraction. All right, let's try a few more here. You can apply the same rule going the other direction. So if I have a negative exponent in the denominator, I can take and move it to the numerator, but make it positive. All right, let's put one more up there. Again, pause the video, try it in your notebook, and then replay the video. Push play when you're ready to check your answer. 1 over r to the negative 7. Pause the video now. Hopefully you got r to the 7th. If you did, very nice job. At this point, if you have any other questions, you should pause the video and you should check in with the teacher. If not, there are a couple other examples I want you to try. All right. Some of the other ones are going to look a little bit more complicated because you might see an entire fraction that is raised to the negative exponent. All right. All this means is that literally the entire fraction should be flipped over. The numerator should go to the denominator, and the denominator should go to the numerator. So as soon as we flip it over, 5 in the top, 4 on the bottom, now the negative exponent can become positive because negative exponents just mean wherever the bases were located. In this case, the base is both 5 and the 4. They were in the wrong locations. So to simplify, this is now easy because 5 to the 4th means 5 fourths squared means 5 fourths times 5 fourths. So we end up with 25 over 16. All right, I want you to recognize that your exponent actually applied to both numbers. So 5 to the 2nd gave us 25, and then 4 to the 2nd gave us 16. So you can apply exponents to both the numerator and the denominator. All right, I got one more for you to try, and when you're done with this one, hopefully you have a better understanding of what negative exponents actually mean. Here's the last one for you to try. 3/5 raised to the negative 3rd power. Pause the video, try this one in your notebooks. All right, if you did things correctly, we should have flipped the fraction. In other words, taken its reciprocal And now apply the exponent to both the numerator and the denominator. So 5 to the third literally means 5 times 5 times 5. So 5 times 5 is 25, times another 5 is 125. 3 times 3 times 3 would be 3 times 3, which is 9, times 3 again, which is 27. I know those don't reduce because the only number that made up the bottom of the fraction is 3, and the only number that made up the top of the fraction is 5. So 3 and 5 have no common factors. And that's a wrap. Hopefully you know more about negative exponents.